Welcome everybody to our next STEM Wednesday. If you are joining us live, great to see you. Let us know where you're joining us from. If you are watching a recording, you can leave a comment on this video and let us know where you're joining from if you are watching in the future. As always, our STEM Wednesday starting at 4 o'clock Eastern time, and stay updated on our schedules. We got some really exciting stuff coming up, a really exciting one for next week. But today we are talking about coding, block-based coding, picture-based coding, and our official title is Start Your Engines, Picture and Block-based Coding for MyBot Explorers. And this will be an introductory type of course or webinar or whatever we want to call this for coding, but it may not be the first exposure to coding. So don't think of this as this is only for young children. This is for those that have started to dip their toes into the world of coding and want to get started with either that picture-based coding or use that as a building bridge into block-based coding, specifically for MyBot, whether you have that MyBot Recruit or the MyBot Fusion. Also, for future reference, if you are watching this recording, it would be very beneficial to have your robot with you on a device while you possibly pull up this video to join along or to access the resources that will be in our description. But a brief overview of our session today is going to follow three basic ideas. First, starting with picture coding, what picture coding is, how to use the basics of picture coding, and then moving into that blockly or that block-based coding and using more logic, ins and outs of if-then statements. And then there will be some ideas for activities to get started. So a lot of things to get you going with students. Even if you don't have robots, there's still a lot you could do with students. And if you have not yet checked it out, we will definitely put a link at the description of this STEM Wednesday, but a fantastic STEM Wednesday to explore and to spend some time with prior to this one. If you've never started with any sort of coding or you need an introduction to robotics, Hannah Olson, our product manager, gave a fantastic STEM Wednesday on using unplugged coding to introduce robots. So basically, before you even log into a computer with students, what are the ways that we can get students thinking and interacting with code that doesn't involve a device? And so that would be a great resource to start. And we are going to build right off of that. We will be mentioning a lot of the things that Hannah talked about in her video and where you could go next with your students. Also, exciting announcement, look for a video tomorrow. We have a video coming out on a new MyBot update that will be available. And so instructions will be coming soon. But yes, new update is currently available for our MyBots. Awesome. And then we got the link in the chat right there for Hannah's previous coding session. Now, a question that I will put out to the audience if you do want to chat and participate, and if you're watching the recording, what I would love for you to think about is ways in which students are getting opportunities or exposure to code. So if you want to let me know in the chat, change that. Make sure to change your typing to everyone. So instead of sharing with hosts and panelists, everyone can see your comments. But my question, I'd love to hear some thoughts on where are students getting opportunities to code? And let's think a little bit different about this. Think of maybe about like unplugged coding, or think about where students are experiencing maybe like sequential thinking. Where might they find opportunities to practice order, or where there is logic, or where they can practice a lot of if-then statements? So for example, I think about students that often express how hungry they are. That's a very simple if-then statement. If I'm hungry, I will go eat food. We have in the comments video games. Students have plenty of opportunities to do things that are very similar to coding in video games. There's a lot of ways that you can input numbers or input things and then get something out. Minecraft, I know, is a great example where you can create things, where you put things in, you get stuff out. It's a very different, but also similar type of coding. And then another option that I thought about was class jobs. I think about a classroom that has a system of class jobs is its own sort of computer system where everything has its own function, where once trained on how to execute a function, that student will execute that function. So if we have a student whose class job is to turn the lights on, every time that something is said or a bell is rung, that student goes and turns the light on. That's almost like coding in a way for students. And it's important to consider why we need to spend more time in coding for students, whether we're introducing it for the first time at the middle school or high school level and students never got that opportunity, or we're introducing it at younger ages, or for ourselves as adults. There are great reasons as to why we should code. Here are a few if you can think about where coding could certainly develop these skills. Oh, I love this comment here. We got also just brushing your teeth or tying shoes. Yeah, a certain function, a desired outcome, and we execute a series of functions to perform that task. So there's a lot of ways that we can introduce that coding. And again, going back to Hannah's video on the unplugged coding is a great place to start. But why do coding? It boosts problem-solving skills. Anybody who's done any sort of coding will know that most likely our codes will not work all the time, and especially not that first time. So when our codes don't work the way that we think, we go back and we can figure out where that problem lies. It also improves that computational thinking, looking at the steps that we actually need to solve a problem. And it really gets students into that computational process of tasks. Definitely encourages persistence. If you are adopting anything like a growth mindset, or you're thinking how engineers fail forward, coding is another great way to continue to build that endurance and that persistence when there is a lot of adversity. This one I thought was an interesting way to explore creativity was through coding, because coding sometimes feels like math where there might be one answer, but then when we think about it, coding gives us a huge tool chest to play around with. And there's many ways that we can go about a task that can be very creative. Teaching digital literacy is crucial at any age. And when we start to see later how picture-based coding leads into block-based coding, which then eventually could lead into Python, we can see how introducing and having intentional moments and times for digital literacy is going to be crucial for students at any age. We see many more careers nowadays that either require or benefit from coding skills. And then the last would be, I feel like one of the most important things is to improve that confidence as well as communication skills, whether they're communicating with classmates on a project or how they're going to work with the robot, or communicating to the robot. How are they communicating what they want the robot to do? And there is nothing greater than watching a student who has struggled and is trying to figure out how to get the robot to do what they want to do. You talk to them, they go back, they try it, and then finally it executes the way that they want. And they have that excitement, that enthusiasm, and that increased level of confidence. Okay, so where do we get started with this exploration of coding? And again, I want to point you to a few things that Hannah has mentioned, and we are going to bridge the unplugged coding into some very basics today. Again, if you have your MyBot and you're following along with us, definitely have the my.bot link set up ready to go so you can code along with us. If you don't have it set up, I will be giving you a link to a series of slides that you could also follow along virtually. But as we go to My STEM Kits, and I see we have a comment as well here saying, fiance and I programmed a website to improve and add variety to one of our favorite board games. Oh, awesome. Love it. So not only seeing how that coding can benefit you in a career, but also in the personal areas of our lives that adds that variety. Love that comment. Thank you so much. So if you have gone to My STEM Kits, and either Hannah or Evan, if you want to put a link in the chat, if you have a My STEM Kits account, or if you would like to sign up for a free trial, and this is something you could easily start with students today, we go into Browse Kits, and in the top left for search, we're going to search the word coding. And one of our kits is called our coding kit. And this is a great resource if you either have a 3D printer or want to see what it might look like for students that are just getting into coding. And this could look like printing tiles and pieces before students are getting into the coding itself. So this could be a great resource for you to start, as well as 3 fantastic lessons that will also work with what I will cover today. So I'm going to show you a virtual version of coding that actually wouldn't require a robot, but you could use rectangle routes, race to the finish line, or planting trees with what I will show you today. But I wanted to point out this as a great tool and resource, either if you have a 3D printer or if you want to access already made lesson plans with what we will talk about today. Awesome. Thank you for putting that in the chat for me, Hannah. And we are going to start, yes, and we also have a 2D version as well. So if you don't have that 3D printer and you just need that 2D version, that is available as well. Our picture coding and block-based coding is where we will start, and then we'll get into some of the activities. In the chat here, I am going to put a link for anybody, and as we upload this video to YouTube, we will have this link as well. And what you will get with this link is the ability to create your own copy that you could either use as an example with your students, or you could give a copy to your students. So if you want to go click on that link, it will force you to make a copy, and then you will have a copy of what I am showing on my screen. So I'll give some folks a second to click on that, make your copy. And this is where we're going to spend a portion of our time today, a majority of the rest of our time. And again, if you have MyBot already up and you're connected to your robot and you're ready to code, feel free to follow along with your MyBot as well. But if you don't have that, or if you want to see what it could look like where a teacher is leading the class on a panel or on a projector, or if students were all doing this on their own Chromebooks where they wouldn't have to have a robot connected to it. There could be many reasons. Not every student has access to a robot. Just the number in your classroom, they may not be charged, another class might be using them. And so trying to provide as many resources as we can to get students involved with the coding is going to be great. On our first slide, we see an example of what a virtual code could look like. So we see this coding kit, and I love this on the second slide. This gives you, I won't read everything. I'll let folks that want to explore and go through this on their own. But on the second slide, we can see a great overview of what these tiles can be used for, as well as ideas to introduce them. So for example, when we go to slide 3, this is what the picture-based code images sort of look like when students get into the MyBot coding interface. When they're using pictures, this is a fantastic resource for students who either don't have English as their first language or students who are just learning how to read. This could be a great resource while keeping in mind you might be limited on what you can tell your robot to do. As we can see with these buttons, we have this blue F for forward, this blue B for back, turning left 90 degrees, turning left at a slight angle, and then doing a full 180. Same with going to the right, as well as speed. We can go very slow, we can go medium or faster, or we can have our robot flash a yellow or a blue light, or yellow and blue. So again, thinking about how just giving students access to these images to play around with is a great way to get them started before we get into the block-based code. And here we can see a few examples of block-based code that would allow a series of code to repeat, would allow a series of code to execute a function, as well as driving, turning on our lights, and rotating. And what we are going to do together is we are going to try out this challenge here. And we're going to start with using any method. We are going to create a program that will make our robot travel in a square. Now, a comment in Hannah says your exact block options will vary based on which robot you have and what version of firmware it is on, which is very important because the colors and the way that the font might look different when you connect your MyBot, again, depending on what robot you're using and what firmware. So again, the latest MyBot firmware is updated, and that video will be up tomorrow. But yeah, let's get into making a square here. And when we get into making a square, let's look at slide number 6. And if you have your own up, you can look at slide number 6, or you can look at mine. And let's take a look at this robot. I put a little robot here and we can see the tire tracks, and I put the tire tracks there so we can tell what direction the robot is moving. And this is where I would spend a huge majority of time with my class, physically standing up and talking out loud what is happening when we code a robot, and focusing on the perspective and the point of view of the robot. Those that are getting started with coding, you just finished your unplugged coding, you're kind of dipping your toes now into actual coding, and understanding point of view is crucial, because here we can see this robot is pointing almost, we could say up, or we could say it's pointing north. If we wanted this robot to, let's say, rotate to the left, I, as the teacher, would drag this tile over and have a conversation with my class and talk about what we're asking the robot to do. We're asking the robot to turn 90 degrees to the left. And so what I would do is I would rotate this robot 90 degrees to the left, and I would use the tools that I see on the screen to physically show my students, because of this code, I can see my robot has turned to the left. Now I need my robot to move forward. And so I could have a forward function, and it would travel forward, and I would move that robot continuously. Now, I won't spend the entire time, because this is a very quick, brief learning lesson. This is to get you started, to get you introduced. But what I am showing you right now, again, is what I would be walking my class through, and I would be talking about how we would make a square. And this next step would be the most important, because this is where a lot of mistakes would happen. Because what code would I use to make my robot turn left? And I feel like a lot of students would make the mistake of placing this tile right here, because like, oh, I wanted to do kind of this little turn to the left, but we are just doing a 90-degree turn in this direction. And I have an activity that I would highly recommend you to start with, to get students practicing and practicing and practicing this idea of point of view and perspective. But if I wanted to use the next step, the block-based coding, and this is where we would definitely encourage students to move into so that they can continue to develop those skills, we could have this repeat function where, after it has executed that one corner of the square where it has rotated left, it has gone forward, I could use the repeating tool. And that would look a little different, again, based off of what robot you have and what version of firmware. But when you have successfully executed your code and we have tested it out, it hopefully would and should look like this. Here's an example that Evan had recorded for me. And here we can see both versions. And Hannah mentioned a very helpful tool, and one of the reasons why you would want to encourage your students to move into the Blockly version is you do get that greater sense of control. You can tell exactly how far you want it to turn, how fast you want it to go. There's a lot more control you can have. And look, you can make them do a little dance at the end. Now, getting a robot to do that is a lot more complicated than it might seem, which is why spending time during these foundational moments is key and is going to be crucial, which is why introducing activities and games is going to be very helpful to give students that reason, that motivation to code their robot. I will talk to you about my activities, but I want to show you on slide 7 some things here that could be helpful for students to do virtually. I have an activity where students create a maze. Some students create a maze and the other students code the robot to maneuver through the maze. You could create a virtual maze using items in slides where students would be rotating and creating a way for this robot to maneuver through a virtual 3D space. And we might have to code the robot and go, okay, it's going to have to go straight. It's going to have to rotate to the left and then continue straight again. And these types of conversations are going to be very helpful to create that foundation, to create that background for students before they get into those things that could be a little more complicated and a little more frustrating for them. So to wrap it up, I have a few activities that I would highly recommend picking one and starting with. The first is Stuffies on Deck. And I feel like any grade level would want to bring in some sort of stuffed animal or toy, but the idea is that students are bringing in a stuffed animal to school. And when they are either using the printed coding tiles or they're using a virtual option to create a program, they are allowing their stuffed animal to act out their coding. And the reason why this is helpful is, again, is it reinforces that point of view and that perspective. Which direction is your stuffed animal turning? Is it turning left? Is it turning right? Is it going forward? Is it going backwards? Is it going to reverse when it bumps into a wall? So having something to for them to physically hold and act out their coding is going to be a helpful step. Another activity is similar to that maze that I showed you. Is called the Amazing Explorers, where you could simply create 2 teams of 2, where one team of students is using items from around the room to create a maze, and then the other team of students are creating the code to maneuver the robot through the maze. They can test it, they can try it again, and then they can work together to successfully navigate the robot through the maze. And then a kind of a silly but a different idea I came up with was one called Lighten Up, where using your robots for a brain break. So using your robots as a way to create something like maybe a would you rather scenario. And this is assuming your robots have their, your students have their robots readily available. They can code them rather quickly because you could have a nice brain break. Students grab their robots, you ask them would you rather questions, and based off of their answer, they could code the robot to show what light that corresponds to their answer. So for example, it could look like this. Would you rather fight 1 horse-sized duck or 100 duck-sized horses? And then students would talk in their group. They would then code whichever light they feel like is their answer. And then the teacher counts down, and then all the robots light up with the color, showing their answer, building that classroom community, and just having that sense of collaboration. So 3 ideas, 3 examples you could start with today, as well as our My STEM Kits lessons that are up for you to use. And my final question, just wrapping it up here with our time, is curious what other ways you want to start using either picture or block style coding, or just coding in general. We had already seen some amazing ideas using a website to improve the variety of board games. We had heard about using coding in video games, using coding and talking about unplugged coding in everyday activities such as brushing our teeth or tying our shoes. And if there's any other ways you want to start using that picture or block style coding, please let us know. One idea that I want to start with my own children is using the Recruit that has the programmable faces, is finding out variations to these activities where there's more customization to sort of the personality of the MyBot Recruit. All right, folks, that is bringing us to the end of our time. Again, if you are watching the recording of this, take a look at the description for access to any of the resources we mentioned today. And we hope to see you next week. We have another exciting My STEM Wednesdays from Hannah. If you caught her Valentine's one, we have a similar one, but themed for our St. Patrick's Day. So coming up next Wednesday, same time, 4 o'clock Eastern Standard Time, as Hannah shows us how to create a St. Patrick's charm in Tinkercad. So hope to see you folks there. Thank you for joining us today. And if you are watching this recording, thank you for checking it out. And we hope to see you at our next STEM Wednesday.